Today, we will dive deep into the wild world of science, tech, and the universe's biggest mysteries. You know those fusion reactors everyone's buzzing about? The ones that could give us unlimited, clean energy by smashing atoms together like mini-stars? Well, turns out they might have a sneaky side gig, producing particles that could solve the riddle of dark matter. I'm talking about axions, these elusive hypothetical particles that scientists think might make up the invisible glue holding the cosmos together. And get this, an international team of researchers has figured out a way these particles could pop out of fusion facilities, not from the fusion itself, but from some unexpected neutron shenanigans with the reactor walls. Stick around, because we're breaking this down step by step. We'll explain what dark matter is, why axions are a hot candidate, how fusion reactors work, and why this new idea is a game changer. If you're into physics, cosmology, or just love a good science plot twist, hit that like button and subscribe for more. Let's fusion this up. First things first, what's dark matter, and why do we care? We know it's there because of its gravity. It holds galaxies together, bends light around clusters, and shapes the cosmic web. Without it, the universe would fly apart. But what is it? Candidates range from tiny black holes to massive particles that barely interact with anything. One top contender? Axions. These are ultra-light particles, way lighter than electrons, proposed back in the 1970s to fix a puzzle in quantum chromodynamics. That's the theory of the strong nuclear force. Axions are dark because they only interact super weakly with normal matter, mostly through gravity. If they exist, they're everywhere, zipping through us right now, but we can't detect them yet. Now, the idea that axions could come from stars isn't new. Stars like our Sun are giant fusion factories, and theories suggest axions might sneak out during those reactions. But the catch? The amounts are tiny. Way too small to detect on Earth. Even from the Sun, which is a massive powerhouse, the axion flux is like finding a needle in a haystack the size of the solar system. Enter fusion reactors. These are human-made stars designed to fuse deuterium and tritium, isotopes of hydrogen, to release energy. The goal? Clean, limitless power, without the radioactive waste of fission reactors. Projects like ITER in France, or private ventures from companies like Commonwealth Fusion Systems, are racing to make this a reality. But here's where it gets fun. Researchers led by physicist Yuri Zupan from the University of Cincinnati thought, hey, maybe axions could emerge in these reactors too. At first, it seemed impossible. Reactors are puny compared to stars. But they had a clever twist. Let's geek out on how a deuterium-tritium fusion reactor works. At the core, you've got a super hot plasma, gas so hot it's ionized, where deuterium and tritium nuclei slam together, fusing into helium and spitting out high-energy neutrons. These neutrons carry a ton of kinetic energy. Around the plasma is a vacuum vessel, and wrapped around that, the breeding blanket. This is a thick layer of lithium-rich material. Why lithium? Two reasons. First, it absorbs those speedy neutrons, turning their energy into heat for electricity. Second, when neutrons hit lithium-6 atoms, they split them into deuterium and tritium. That tritium gets recycled back into the fuel. It's called a breeding blanket because it breeds more fuel. Super efficient. Now, the old idea was to look for axions from the plasma itself, like in stars. But Zupan's team said, nah, that's not going to cut it. They calculated that the axion production from plasma is too low. Just like Sheldon and Leonard joked about in the Big Bang Theory. So, the team shifted focus to those high-energy neutrons blasting into the breeding blanket and reactor walls. Billions of neutrons per second, folks. That's a flux that's off the charts. They modeled two key processes: neutron capture interactions. When a neutron gets absorbed by a nucleus in the blanket, like lithium, it could trigger the creation of an axion or axion-like particle as part of the energy release. Neutron bremsstrahlung. That's German for breaking radiation. When a neutron scatters off another particle and slows down, it loses energy, which could convert into axions. The math shows these processes could crank out way more axions than fusion plasma alone, potentially detectable levels leaking out of the reactor. Why is this a big deal? Detecting axions would be huge for physics. It could confirm dark matter's identity, explain why the universe has more matter than antimatter, that's the strong CP problem axions solve, and open doors to new tech or understandings of the cosmos. Plus, fusion reactors are already being built. We don't need a dedicated axion hunting machine. We can piggyback on energy research. Imagine, while generating power, these reactors become dark matter factories. Detectors could be placed outside the walls to catch escaping axions, maybe by looking for their rare decays into photons or interactions with magnetic fields. Zupan puts it perfectly. The sun is huge, producing tons of power, so axions from solar processes have a better shot at reaching us. But reactors can use different processes to make them detectable up close. The team's work was published in the Journal of High Energy Physics, solid, peer-reviewed stuff. Of course, this is theoretical. We need experiments to test it. Future fusion facilities like ITER could be tweaked for axion searches, adding sensors without messing up energy production. Pros of this idea: dual purpose, energy and science in one. High neutron flux in reactors beats natural sources for these specific processes. Could detect low-mass dark sector particles beyond just axions. Cons: fusion tech is still maturing. We're not at commercial scale yet. Axions might not exist, or the flux might still be too low in practice. Safety: fusion is safe, but adding detectors means more engineering. Still, it's exciting. This turns impossible into let's try it. It shows how pursuing clean energy can unlock cosmic secrets. What do you think? Could fusion reactors crack dark matter? Drop your thoughts in the comments. Are axions the real deal, or is dark matter something wilder? If you enjoyed this, smash that like button, subscribe, and turn on notifications for more science deep dives. Thanks for watching. Remember, the universe is full of surprises. Keep questioning, keep exploring. See you next time.